Welcome back to the Deep Dive. If you're looking to get a fast, authoritative shortcut to understanding the next wave of AI infrastructure, you are definitely in the right place. Today, we are cracking open the blueprints for truly scalable AI applications. We're moving far beyond just simple language model prompts and really getting into enterprise architecture.
We are. We've been looking at this really fascinating technical demo, and it outlines two foundational elements: the AI agent, which is highly autonomous, and this coordination engine called the Model Context Protocol, or MCP.
MCP.
And for anyone out there building or, investing in advanced AI, the relationship between these two, it's the difference between writing a script that does one thing and designing a system that can run an entire complex organization.
So we're moving from just simple execution to full-on integration.
That's our mission today: to cut through the jargon and show you exactly where the agent's authority ends and where the MCP's, well, its necessary orchestration really begins.
Okay, so let's unpack this. I think we should start with the part that gets the most excitement. The AI agent.
Good idea.
You can think of it as, I don't know, the specialist contractor on a job site. It's the doer.
It is the doer. And when we look at the source material, the definition isn't just about, spitting out text. It's about being an autonomous performer that executes complex actions.
That's a huge distinction, that word autonomous.
It's crucial. We're talking about independence. And the sources point to 5 core functionalities that really define this level of autonomy. Together, they define the agent's, let's call it tactical ability, its skill in the moment.
Okay, let's run through those 5, because they really show the surprising breadth of what an agent could do. Number 1 is pretty straightforward: autonomous action.
Right.
The agent basically takes the wheel, it runs with the job without needing constant micromanagement, just executing tasks based on its initial set of instructions.
But that leads to this fascinating tension, which is feature number 2, human control.
Yes. Despite all that independence, our sources explicitly say that human oversight is still necessary. It's not a nice-to-have.
No, it's an architectural requirement. You need to be able to guide, to intervene, or, course correct a runaway task. It's the human architect double-checking the specialist's work.
Exactly. And that human guidance is so essential because of the next 3 features, which, they allow the agent to interact with the real, messy digital world.
The agent is not a contained black box, not at all.
So feature 3 is how it actually gets things done. Tools and API calls. This is how the agent steps outside its own little memory bank and connects to external services or data.
It's how it plugs into the existing digital infrastructure to do real-world tasks.
And feature 4, which kind of enables that, is internet access. The agent can connect to the open web for retrieval, for searching, for finding current information.
Or just interacting with various web-based tools. It's capable of real-time data ingestion.
But the 5th one, this is the one that I think is truly transformative: memory and interpretation. Yep. The source material points out 2 things here. First, the agent can remember past interactions, which gives it context beyond just the immediate prompt.
And second,
it can interpret code for advanced operations. This means it doesn't just execute code, it understands its structure, its logic.
That's the key. So if we pull all 5 of those together, what do we have? The AI agent is fundamentally about rapid, independent execution.
And interaction with its immediate environment. It excels at fast, intelligent action, at decision-making speed.
It's the specialist who can quickly fix a super technical problem using the tools you give them.
Right. But action in isolation only gets you so far, especially when the task involves, say, sensitive corporate resources or multiple systems that are all interconnected.
Exactly. If the agent is the specialist, then you need someone to build the roads, manage the traffic flow, and make sure there's standardized communication across the entire environment.
And that's where the Model Context Protocol, the MCP, steps in.
The MCP is the infrastructure architect. It's designed specifically for these environments where you have, heterogeneous systems.
Meaning different servers, different data formats, diverse APIs.
All needing to speak a standardized language and coordinate their efforts, securely and scalably. It's less about the individual task and entirely about the framework that enables that task at scale.
Okay, so let's break down the structure of this MCP architecture. It has 3 core components, right?
Right.
And it starts with the brains of the operation, the MCP host.
The MCP host, that's the central control hub, the conductor. It orchestrates all the communication flow and task allocation among the clients.
And crucially, the host handles the core AI integration itself, connecting to models like Claude. It also provides user interfaces like IDEs for the human operators.
It is the master server. Then you have the MCP clients. If the host is the strategy center, the clients are the deployment layer. They execute tasks using this specialized MCP protocol, and they act as standardized gateways that connect the host to specific, often siloed bits of infrastructure. The source calls them server A, server B, server C, and so on.
And that brings us to the backbone, the MCP protocol. This is where the magic of standardization happens.
It really is. It's a specific communication protocol that ensures seamless interaction between the clients, the servers they connect to, and any external services. Think of it like a universal corporate translator for AI systems.
Okay, I have a fundamental question here, and I bet you, the listener, might be asking it too.
Go for it.
If the agent already has internet access and can make API calls, why do we need this whole MCP architecture to connect to, say, Google Drive or GitHub? Can't the agent just grab an API key and go direct?
That is an excellent question, and it gets right to the heart of why MCP even exists. The agent can technically grab an API key and go direct, but that model fails instantly at enterprise scale and security. Instantly. MCP provides reliability, it provides standardized access. The sources highlight that MCP clients connect to these high-value assets like PostgreSQL databases, GitHub code repos, Slack channels. You do not want an autonomous, potentially unpredictable agent randomly accessing those high-security systems with global credentials.
Ah, okay. So the MCP acts as the secure, controlled proxy.
Exactly.
It makes sure that every single interaction with that PostgreSQL database, for example, follows a structured, compliant protocol that's defined by the host. It's not relying on the agent's immediate and potentially unique decision-making process.
You got it. It provides that necessary standardization and security buffer. The MCP's focus is on secure communication, verifiable data exchange, and the orchestration you need to tie those different high-level corporate resources together reliably.
This is not about speed of action.
No, it's about safety, compliance, and guaranteed data integrity across the entire workflow.
Okay, let's take that distinction and transition into the direct comparison, because this is where the value proposition really comes alive. They're not competing systems.
Not at all. They're designed for fundamentally different levels of complexity. When we compare their focus, the agent is narrow and deep.
Right, focusing on autonomous action, on memory, on that immediate interaction to get a specific part of a task done.
Whereas the MCP is wide and structural. It's focused on orchestrating the complex interactions between multiple independent systems, clients, servers, data sources, you name it.
So the agent is executing the high-level steps. The MCP is making sure all the low-level infrastructure is available, secure, and coordinated.
I like the analogy you used earlier. The agent is the driver, but the MCP is the integrated transportation network. It makes sure that traffic lights are working, the gas stations are stocked, and every road is properly labeled.
Okay, so now let's dive into the integration point, the synergy. How do we put this specialist contractor, the agent, inside this highly structured corporate environment of the MCP?
This is the crucial connection. The AI agent can operate autonomously within an MCP-based environment, so the agent gets a high-level goal, but instead of connecting directly to the infrastructure.
It interacts with the MCP clients.
Exactly. It interacts with the MCP clients to gather data or trigger processes. The MCP becomes the agent's interface to the entire organization.
Let's illustrate this. Let's use a concrete scenario because I think you really need to see the how here. Imagine the high-level goal is to resolve and document a bug reported on a critical internal system.
Perfect. Okay, so the agent receives that goal. Now, the agent doesn't then just go diving directly into GitHub to check the code.
Right.
Instead, the agent realizes, okay, I need the ticket history. So it sends the request to the MCP host.
And the host then tells the relevant MCP client, let's call it the data client, to run a query.
Right. And that data client, using the standardized MCP protocol, securely queries the PostgreSQL database for the bug's history. This ensures only compliant queries are run and the database stays stable.
The data client then gets the raw data, hands it back to the host. The host, using its built-in Claude integration, summarizes that complex database output into something a human or an agent can actually read.
And now the ball is back in the agent's court.
The agent gets the summary. And because it has that ability to interpret code, that was feature 5, it decides a code fix is needed. So it sends a request to a different MCP client, the code client, to create a draft fix in GitHub.
And the code client manages that whole interaction with GitHub. It might trigger a pull request, draft the necessary files, Finally, the agent sees the new code draft is there and instructs the host to send a confirmation notice via the Slack MCP client.
Wow. So the MCP's role was to organize and structure that incredibly complex multi-system task, PostgreSQL, Claude, GitHub, and Slack, while the AI agent was responsible for the intelligent decision-making at each pivot point.
Deciding what to query, what code to draft, and when to send the final notification. It is the structure enabling the execution.
That synthesis is what drives the real-world value. The MCP provides the safety rails, the standardization, the secure connectivity.
And the agent provides the fast, high-level intelligence that determines the path through that structured environment.
Now that we fully appreciate that synergy, let's detail the collective benefits of running these two systems together, how they solve real architectural problems. Our sources list 3 huge advantages, starting with scalability.
This is the critical architectural benefit. Because the MCP is built with that host and client model, the whole system is inherently modular.
Meaning you can add new pieces easily.
You can add 3 new clients and connect them to 3 new servers, a CRM system, a logging system, a testing environment, whatever, without having to rewrite the core agent logic. The MCP architecture just supports that expansion seamlessly.
The agent just issues a high-level request, and the MCP routes it to the right, newly added client. That has to drastically simplify architectural growth and maintenance.
It does. Then the second benefit is enhanced autonomy and flexibility. Because the AI agents are operating within that predictable, structured MCP framework, their decision-making speed goes up dramatically.
Why is that?
It's because the agent doesn't have to worry about things like data format conversion or security clearance for external systems or establishing new connections. The MCP guarantees the data pathways are clear and compliant,
So it frees the agent up to just focus purely on the task at hand.
which accelerates the whole workflow's efficiency. And finally, the third benefit, which we just detailed, integration with external systems. The MCP provides that single, unified gateway. For an enterprise, that means leveraging everything from critical legacy systems to modern cloud tools like Google Drive or GitHub, all through one standardized protocol.
So if we connect this to the bigger picture.
The conclusion is pretty unavoidable. Together, the agent and the MCP form the essential combination for deploying truly complex, enterprise-grade AI. They deliver a system that is efficient, scalable, and capable of handling multiple interconnected tasks securely and reliably.
The structure allows for the brilliance of the execution.
Well said.
Okay, so to summarize our deep dive for you, if you're building these solutions, remember this dichotomy. The Model Context Protocol provides the robust architecture, the secure infrastructure, and that standardized communication layer across all your systems.
While the AI agent provides the tactical, autonomous decision-making and the hands-on action within that structure.
Projector and the specialist.
Exactly. And here's a final provocative thought for you to mull over as you think about the future of AI architecture. We said the agent's defining feature is its ability to interpret code and access memory.
Right.
Now, what happens if that highly capable code-literate agent is operating inside an MCP environment? An environment that provides secure, standardized access to the enterprise's mission-critical code repository in GitHub. What revolutionary leaps in autonomous software development and infrastructure management are we about to witness?
The potential to link that level of intelligence with that kind of structure is, well, it's truly massive. Thank you for joining us on this deep dive. Now you know the core difference between the conductor and the specialized doer and why their seamless integration is rapidly becoming the benchmark for advanced AI. Keep exploring.